So our topic is going to be the inverted page table. And to start off with, we're going to explain what an actual page table is. Um, it's used by the computer operating system to map out between the virtual address and the physical address used by the hardware, more specifically by the RAM. So here we have a page table. Um, the CPU has a logical address that it generates.
My name is Moiwa Koka and I'm the CPU. I generate the logical address for the operating system.
So here we have a page table, and within the page table, these are going to be looked at as frames. And within every frame is a process that is sent to the physical memory. So this is basically how a page table works. Um, the CPU provides me with a logical address. I go to the page table and I look to find this address. And once I find it, I take the page and is now converted into a physical address, which then gets put into physical memory. So this is also an inverted page table. It looks just like a page table, except there are a few differences between the page table and inverted page table scheme and how it works.
So, because in a page table, every process requires a page table to be executed in the memory. So the processes and the page table will take more spaces in the physical memory. So to solve the problem, we need to use an inverted page table. So think of these arrangements as an inverted page table and all these books as processes in the page table. So what happens is the CPU will generate the PID, which is the process identifier, and the page number and the offset. So the PID and the P will go into the page table to search where the process is. So as soon as it gets the process, it translates the PID and the P, which is the process identifier, and the page number will generate the index. So the index with the offset that is generated by the CPU will translate to the physical address that goes into the memory, and this is how it works. This is the CPU. The CPU generates the logical address. And so this is how it happens. It generates the PID. The PID is the process identifier, and the P is the page number, and the D is the offset. So what happens is the PID and the P will go into the page table to search where the process is in a linear order, and this is how it happens. So what happens is when the PID and the P goes into the page table, it checks linearly to see where the process is, and as soon as it finds a match, it will generate the index. The index will combine with the D, which so it takes the process into the physical memory, because that the physical memory uses the physical address. And so so the advantage of that is that because it's just a process that goes into the physical memory, so it creates more space in the physical memory compared to when an ordinary page table will move as more processes that is associated with more page tables. So that is the advantage of using the inverted page table over a regular page table. Thank you.